Hello, my amazing viewers. You are all welcome back to this channel, Prof. 1 Tutorials. Today, we would like to look at another question under Core Math WASSCE 2025, question 11. So from the question we have on the board, a cardboard is in the form of an isosceles triangle with vertices A, B, C. Distance AB is equal to distance AC, which is also equal to 2p plus Q or meters. Again, distance BC is also equal to 3p plus 5 or meters. And the perimeter of the cardboard is 7Q plus 3 or meters. Illustrate the information in a diagram and the B, given that P is to Q equal to 2 is to 3, find correct one decimal place the value of P and Q, and again the area of the cardboard. So let's look at the solution quickly. So we have A, B, and then C. So viewers, this is a triangle. And the question made it very clear that it is in the form of an isosceles triangle. And we know that isosceles triangle has two sides equal. So from here, AB is equal to AC. So AB is equal to AC. They all have equal distance, which is 2p plus Q. So we have here to 2b plus Q. Here is also 2p plus Q. And distance BC is 3p plus 5. 3p plus 5, or meters, or in meters, and everything here is in meters. The question continued by saying that the perimeter of the cardboard is 7Q plus 3. From mensuration 1, when you talk about perimeter, is the sum of all the sides of the plane figure. So here we have 2p plus Q to be the distance over here. Then we also have 2p plus Q to be the distance over here, plus the distance here, which is 3p plus 5, and everything should be equated to 7Q plus 3. So we have 7Q plus 3. So from here we are going to put everything together. But before that, let's group like terms. So we have 2p plus another 2p plus another 3p. Then after that, we will sort all the Q out. So we have positive Q here, another positive Q here. Then we have 5 left. Is still equal to 7Q plus 3. Now let's put them together. 2p plus 2p, we have 4p, plus 3p, we are getting 7p, plus Q plus another Q, we are getting 2Q, plus 5 is still equal to 7Q plus 3. So from here we have 7p here, we have 2Q here. Then when this 7Q comes to the other side, we are getting minus 7Q, which is equal to, then I have 3 here, then I'll bring the positive 5 also here, giving me negative 5. So I brought 7q here and I took 5 there. So from here, we are going to still evaluate. So I have 7p. Then from here, 2q minus 7q, we are going to get negative 5q. So negative 5q is equal to 3 minus 5, we are getting negative 2 to be the first equation, equation 1. The question continued by saying that given that P is to Q is equal to 2 is to 3. So we are going to look at how we can also deal with the ratio, then get the values of P and Q. Alright, so we have P is to Q is equal to 2 is to 3. Ratio basically means fraction. So P is to Q is the same as P over Q, which is equal to 2 is to 3, which is also the same as 2 over 3. So from here, we are going to cross multiply. So this multiplies that, this also multiplies this. So P multiplying 3, we have 3P, which is also equal to Q multiplying 2, we are getting 2Q. So from here, we are going to make P the subject. In view of that, I'm going to divide through by the coefficient of P. So this takes off this, then I have P to be 2Q over 3. So now let me take this off. So this will be my second equation, equation 2. Now I'm going to substitute equation 2 in equation 1, which will help me to get the values of P and Q. So substitute equation 2 in equation 1. I have equation 1 to be 7P minus 5Q is equal to negative 2. So I'll just substitute 2Q over 3 at where I get P in equation 1. So I have 7 multiplying 2Q over 3 minus 5Q is equal to negative 2. Alright. So from here, this 7 is the same as 7 over 1. So this 7, which is the numerator, will multiply 2Q, which is also the numerator. So we are getting 14Q all over 1 being the denominator, multiplying this 3 being another denominator, we have 3 minus 5Q, which is still equal to negative 2. I'm going to multiply through by the LCM, which is 3. So I have 3 times 14Q over 3 minus 3 times 5Q, which is equal to 3 times negative 2. Multiplying through by the LCM. This takes off this. So now I have 14Q minus 3 times 5Q, I have 15Q, which is equal to 3 multiplying negative 2, I have negative 6. 14Q minus 15Q, I am getting negative Q, which is equal to negative 6. And when you get here, we are going to divide through by negative 1. So negative 1 here, negative 1 here. This takes off this also takes off this. So I have Q to be equal to positive 6. Since I have Q to be positive 6, now I can easily get the value of P, because from equation 2, P is equal to 2Q over 3. All right. So from equation 2, I have P to be 2Q over 3. So P is equal to, now I have the value of Q to be 6. So 2 multiplying 6 over 3. So from here, 3 goes here 1, 3 goes into 6 2 times. So I have P to be 4. Because 2 times 2, I'm getting 4. Therefore, the value of P is 4 and Q is 6. So these are the values of P and Q. Now, this is A part. When you check the B part, the question said we should find the area of the cardboard. The cardboard is still in a form of an isosceles triangle. Now we can now get this side because we have the values of P and Q. So from here, if I want this distance, which is 2P plus Q, I'm going to make substitution of the value of P and the value of Q. So I have 2 multiplying P is 4 plus Q, which is 6. 2 times 4, I have 8 plus 6. And 8 plus 6, we are getting 14. Meaning, this side is A, we have B, we have C. This side is 14 meters. And it has the same dimension as AC. So AC is also 14 meters. Now let's look at the distance BC, which is also 3P plus 5. We have the value of P to be 4. So 3 multiplying 4 plus 5. 3 times 4, we have 12 plus 5. And 12 plus 5, we are getting 17. So we have BC to be 17 meters. All right. Before we can get the area, we need to get the height of the triangle. So the height H. We have the base to be 17 meters. And the base will help us to get the height. All right. Now, because of the short dashes, it has divided the base into 2 equal parts. And you're getting a right angled triangle. So I am making this point here as X, point X. So from the right angled triangle, which is AXC, I have AC to be 14 meters. And I have AX to be H. Then I have BC to be 17. But XC is half of the BC. So from here, I'm going to divide the 17 into two equal parts. And 17 divided by 2, we are getting 8.5 meters. Before I can get the height h, then I'll be using the Pythagoras theorem because you are dealing with right-angled triangle. So with Pythagoras theorem, I'll first of all square the hypotenuse. So I have 14 squared is equal to h squared plus 8.5 or squared. So we have 14 squared to be 196 is equal to h squared plus 8.5 squared. We are getting 72.25. So from here we are going to group like tens. So I'll bring the 72.25 to this side. I have 196 minus 72.25, which is still equal to h squared. So 196 minus 72.25, we are going to get 123.75, which is equal to h squared. And from here, we are going to take the square root on both sides. So square root of this and the square root of this. This will cancel the square root, and we have h to be equal to square root of 123.75. So from here, the square root of 123.75, what did you get? So we have 3 root 55 all over 2 meters. So we are going to look at the area of the triangle or the cardboard. So now let's get the area quickly. So now the area is equal to half times the base times the height of the cardboard. So we have half times, we know that the base is 17 meters. So 17 multiplying the height, and now we have the height to be 3 root 55 all over 2. And from here, we can just evaluate right from here. So we have the area to be equal to, now we know that this is over 1. So the numerator multiplying this, 1 times 17, we still have 17. Then 17 multiplying 3 root 55, we are going to get 51 root 55 all over 2 times 1. We still have 2 times 2. We are getting 4 meters squared. But from here, the question said we should correct to one decimal place. So we need to get the decimal of the 51 root 55 all over 4. So the decimal of this is 94.5565 meters squared. So here, to correct to one decimal place, we know that after the decimal place, the first digit is this 5. Because what is following is also 5, we are going to add 1 to this. So we have the area of the cardboard, the area of the cardboard is 94.6 meters squared, into brackets 1 decimal place. The value of P will be 4.0, and the value of Q will also be 6.0, because the question said we are to correct to 1 decimal place. So each of them must be 0.0 because they are whole numbers. So we are going to end here for today and look at the next video. We are going to look at another question in my next video. Continue watching, keep in touch, stay safe. May the Lord be with you all. Bye bye. Don't forget to share the link. And if you haven't subscribed yet, kindly subscribe. Like this video. Bye.